Hello. Is the mic working? Yeah. Okay. All right. Yeah. Hi, everyone. My name is Barnabé. I'm at Protocol Architecture at EF. And today's talk is what we want from our nodes. And to discuss this question, I brought a little friend of mine in this old school Protocol Berg first edition bag. This is actually my staking node, the one that sits in a closet by my living room, and that usually makes me money. So yeah, this talk is costing me 10 euros from the penalties and the rewards that I'm missing. But I wanted to show you what it looks like today. And I have to say that my node is going through a bit of an identity crisis. He's wondering what the future holds for it. He's hearing that he may need to become something like a big rack of servers or a data center. He's also hearing that he may need to become a smartwatch. So he's a bit confused what the direction is for him in the future, or for it, sorry, or for her. Yeah, he's hearing that from different people. So on the one side, maybe Donkrat telling him, you know, we should like be beefing up the network, so you have to get bigger. And on the other side, Justin telling him, you're going to be staking from your smartwatch, and the future is going to be bright. And so this talk is about trying to understand like why, yeah, what the future might hold, because we even have like different shapes that this could take. So for instance, just operating from behind a wallet. Okay, so I think my big message here is we focused a lot on the how, so like the form factor of this node, and saying, yeah, we have to preserve this and make sure that we can always have this exact machine working for us at home. But I think it's important to understand what we want exactly from our nodes, and then try to reverse engineer the shapes that it should take and the roles that it should take, given what the network really needs. And so here's what a node does today. There's a few roles that it takes through the assignment that the protocol gives it. FFG is the security gadget, so finality of the chain. The node performs censorship resistance by producing blocks. It also is an RPC. It does LMD ghost, a fork choice. It allows other people to sync and is part of a sync committee. And it proposes block as a proposer or as a builder. That's a lot of roles. Today I want to focus mainly on three roles. The first one is attesting, so voting on the state of the chain. The second one is including, which is the act of ensuring that certain transactions enter the transcript of the chain. And the third one is building, so emitting a block to the rest of the network and sequencing it. You can think of it as the first one is essentially what gives us security. So we want a secure network. So that's why we have a consensus mechanism, and that's why we have finality. The second one, inclusion, is really about censorship resistance. Like we want any valid fee-paying transaction to be able to enter the chain. And the third one is scale. We want our blocks to be as large as possible because we want to serve as many users as possible. And so we have like this trade-off of keeping the networks within certain bounds that yeah, help us preserve all of these properties at the same time. So let's move from the what a bit to the who and the how. So discussing like what shapes does this take today for the roles of building and including. So you can think of different types of operators, like different types of machines that are run by people or entities in the world. I like to make a distinction between home operators and commercial operators. It's a pretty cartoonish distinction. It's not so binary in reality. You can think of it as there's a group of people running nodes that we don't trust a priori, like they don't have a real-world signal of reputation or credibility. So these could be like the home nodes. And you have another category, which is more like commercial nodes. So they may have a company, a DAO, or something that is like running the thing that runs their operations. And then you might have like more signal of their a priori trust. That's one dimension. The other dimension is, let's say, the resources. So you can have nodes that have fairly minimal resources, like this one, or you can have nodes that require higher resources. And when I say resources, I don't actually only mean computing resources or bandwidth, but it could even be things like order flow. So accessing order flow is one of the key material that you need to make good blocks today. So how does my node perform some of these services? As a local builder, so when my node is making blocks itself, it performs the role of including transactions, it performs the role of building, and as a participant in the consensus mechanism, it also performs the role of attesting. So that node can do all of it. But today, of course, what we've observed and what we've also designed for is that many nodes outsource the building function to a network of builders. That's also what my node is actually doing. This is called PBS, Proposer-Builder Separation. So moving out the role of building outside of the node. So the node is still the proposer, still has to sign, but the block is built and sequenced by someone else, which is this a priori bigger machine that has access to better resources, more order flow, and all of these things. So now we have a bit of an issue because my node was essentially performing the censorship resistance role through the act of building the block. But now that I'm giving the block to someone else for being built, I'm not really able to do that role anymore. And so the role of a node to be this includer now is a bit in jeopardy. So we have to think about how to fix that. We have, in fact, two issues with the building network. So the first one is, you don't perform as well censorship resistance when you outsource the building function to a different role. And then you also have a problem of liveness, like you want to make sure that when you make that call to the builder network, it eventually returns a block so that the chain is live. And you don't want it to be such that the network is held hostage by this external network of builders. So I'll discuss like these two issues in turn. So the first one, our proposal is fossil. It's not something that's already on-chain, but it's something that we think is quite important to include soon. And it allows, essentially, for every round, 16 validators sampled at random, so 16 of these nodes, to create what we call transaction inclusion lists. So even if I'm not the builder for that slot, for that block, I'm able to communicate to the network there's a package of transactions that should be included in that block. And the network is going to enforce that and require that the block that is eventually built, either locally or by the network of builders, must include the transactions that are part of this inclusion list. And so that's a very tight constraint around, let's say, a more powerful, more centralized machine, which is the builder machine. So going back to this picture, now my node is able to perform this inclusion role by using fossil, and that effectively constrains the builder node when they are making the block. This is nice because when we have these bigger machines, it can also give us scale. So I think we can get, have our cake and eat it too. It's okay, that's the first issue. Second issue is liveness. What if the builders don't make a block or they extort us? So here, the argument is a little bit subtle. What we want, what can be nice, is having this picture in mind. So we have this broad base of small nodes or toasters at home that are performing the attestation, that are really like defending the network and that run on as low hardware as possible. But we could find it appealing to raise the target throughput of the chain to a level that's higher than what the nodes themselves can produce, and ask the builder nodes to fulfill that throughput for us. So this is nice. It gives us scale, more users. So that is good. So we have this broad base at the bottom and then a fewer machines at the top that make the blocks for us. This is reasonable. It doesn't mean we can do that like to infinity. There's a bad case where we effectively design the protocol in a way that we make it very, very constraining, or we need like very high resource requirements for becoming a builder, and then we end up becoming on data center. So that's definitely not something that we should be getting into. But the argument for why there is a sweet spot that's further away from what this node can do and still not at the data center level, I think can be made and should be made. And I have written a post more recently, decoupling throughput from local block building, that essentially tries to make this argument. Okay, so that was the who and the how for building and including. Now I want to talk a bit about the attesting role, so the consensus role. today, our consensus mechanism enables direct participation of solo stakers. So solo stakers are the ones who have their own stake, have their own node, and that directly sign up to be a validator to the consensus protocol. This is what this node is doing. But solo stakers are actually a fairly, they're a subset of a larger group of operators that we could say are the home operators that don't necessarily need to be running only their own stake. So we see now more and more these protocols, so Rocket Pool, the Lido community staking module, that allow people who are a priori untrusted, like myself, to receive some stake on behalf of other people who delegate it to them. And as a home operator, then you can make essentially better returns, because now you are also performing the service that you're performing for yourself on behalf of other people. And that can be an appealing proposition for economic sustainability, let's say. And so I feel that with this model and with the outsourcing to builders and having Fossil in place, we really have a home operator Bronze Age, if you will. This little machine can do a lot, but it can also outsource certain things. It can attest to its own view. It can get good value blocks from builders. It can also perform censorship resistance with Fossil, and it can receive extra yield from the delegated stake that it stakes on the behalf. And so I feel that this is a nice picture that makes this node operation stronger rather than weaker. Another element to throw in the mix is that the how is changing. So my node looks like this today, but I would wager that within a couple of years, the picture will be very different. And why I would make that bet is that the tech is changing. We are accelerating really fast on two key fronts. The first one is zk-EVM, so having the ability to verify blocks extremely cheaply, given a proof, and data availability sampling, which is the ability to verify that the chain is live and available without necessarily receiving all of the data yourself. And so these two things are really going to shrink what I need from my node, and maybe bring us to this smartwatch meme of being able to run all of these operations from a much lighter machine. So with succinct zk-EVM verification, I don't need to run like the whole block execution myself. With statelessness, I don't need to hold the whole state. That's also something I get from zk-EVM or from a tree change. With DAS, I can just sample the data of the chain. This is great. And with history expiry, I don't even need that much storage on my node either. And so that really makes it much, much lighter. But the thing that remains is if I want to stake on my node, I still need to provide the money for it. And that's this cost of capital is not going to shrink. And so that's kind of a trade-off now. So we're saying, you know, this node can be much, much smaller than it is today, but you still need like to be able to stake and to make a good enough return to be competitive at that layer and to be economically sustainable. And so I think given that there are other things that we want, such as fast finality, we should ask the question of, what this looks like in the future. So today, our finality comes every 12 minutes, so that's pretty long compared to other networks. And we also have slot times, which are fairly long, at 12 seconds. But in the future, I think we should want high and fast finality in the order of seconds, as well as shorter slot times, let's say from 1 to 4 seconds. The problem we have is that because we have all of these machines, all of these solo stakers on the network that are directly participating, we need to have these much longer delays to get to finality or to have shorter slot times. And so what we may want is a smaller set of attesters to get to these faster properties. There's two main designs to get there. One of them is the capped validator set, so saying there's only this many people that can be part of a validator set. This is what most networks use, such as, let's say, Cosmos networks. The other design is what we call Orbit, which is anyone can join the set with minimum balance, but they get rotated in and out of a consensus mechanism. That sounds like it's it's an appealing property to have, but it's actually a much more difficult mechanism to put in place because of the rotation. And so what we may want in the future from our nodes is not to directly participate in the network, but to participate as part of protocols such as fractional staking, so Rocket Pool and Lido community staking module. So I become a heavier staker by accruing stake on behalf of people that delegate to me, or as part of distributed validator networks where a bunch of solo stakers pool their capital together and run a single logical operation. So we may want to favor indirect participation to the protocol such that the protocol has a smaller overhead and then faster finality and shorter slot times. So there's a lot of questions around this. The question is really not settled. I've tried to explore this in another post, which is called Paths to SSF Revisited. Okay, another thing that may change with this future is we could even have very, very light nodes such that they fit behind your wallet. We have this proposal, one from Vitalik, the local node favoring Delta, and one from Thomas, validity only partial statelessness. So we can really shrink the footprint of a node while still allowing it to be useful and to perform these roles for the network. In particular, the role of inclusion, so the role of censorship resistance. So in the model that we have for Fossil today, we want to attribute the ability to make this inclusion list to the attester nodes, such as this one. But we think that designs are possible where anyone with a wallet that has a positive balance could just sign up to become one of these includers. This is enabled by the new tech of statelessness and some of these designs of partitioning the state between different wallets. And I think this could be very powerful because we could move away from the idea that these are the types of machines that perform censorship resistance for the network to something that's much more like a swarm that may be unreliable for any given wallet, but as a whole is a very robust mechanism to ensure that the transactions that are seen by these wallets keep entering the chain. So what do? I think there's a lot of possibilities. Essentially, the picture that I think we want to get to is this one, where we have cleanly separated the roles, and they're all kind of keeping each other in check, like these little crabs. So we have powerful machines on one side, but they're kept in check by the attesters that are delegating to them, and by the includers that are making the inclusion lists. The includers are also keeping in check the attesters, making sure that they are enforcing the censorship resistance of the network. And I think this makes the network pretty resilient to have everything a bit unbundled, not dependent on a single type of nodes or a single type of operator or a single type of entity, but really having this push and pull between different groups that are trying to keep each other in check, I guess. So designing for this future, I think is pretty hard. There's many different shapes that it could take. The tech is changing quite a lot, and it's easy to get lost thinking about all the different rotating shapes and how to get there. So my personal opinion and what I'm pushing now is thinking more about this short-term goal of accelerating the tech, so scaling the L1 with ZKVM, scaling the blobs with data availability sampling, and improving UX, which is actually what I'm focusing on right now. You can talk to me about that after this. And I think we should ship all of this awesome tech and then revisit what we want from our nodes, but with the idea that, there's a bright future ahead for them. That's it. Thank you.
Thank you, Barnabé. We have time for questions, so we have plenty of questions to answer. I'll start with the topmost one. How many years until we can do ZK verification of blocks on Ethereum mainnet?
So actually, you can do it today. So that's one of the breakthroughs that happened a couple of weeks ago. We are able to now prove blocks within the slot time, so within 12 seconds for most blocks. So it's not reliable enough that we can just directly enshrine it in the protocol, but the latency has already decreased quite a bit. We also need to make sure that these proofs are sound, so that they accurately prove the execution of the block. So there's still a lot of let's say, testing to ensure that we can just rely on it and that my node can stop executing and just rely on these proofs. But already today, these proofs exist, and you could use them to verify certain blocks. So I think one of the things that we've been toying with is the idea of optional zk-AVM verification, where some nodes could be running these verifiers without re-executing everything. So yeah, the tech is really coming quite fast.
The next one, will every computer in the world eventually become an Ethereum node?
Yeah, so that's kind of a message also of this talk is, what is an Ethereum node? So today we have like this idea of a full node, but in the future, with all of these like different variations and flavors of nodes, there could be many different things that we call an Ethereum node. So yeah, I hope that every computer in the world would run an Ethereum node, or would be engaging with a network one way or another. Maybe it's like in the lightest way possible, with like this wallet-enabled inclusion role. Maybe it's with like much beefier hardware if you're like an enthusiast and you want to perform like different services. But yeah, hopefully we get to this world where ETH is just like a silent protocol at the back. Yeah.
Does geographic separation of nodes cause latency issues contribute to fast versus slow finality?
Yeah, so the reason why we have like these longer slot times is, we do want to be fairly permissive with the propagation of the blocks. So of course, like the more you restrict the slot time, the lower like the threshold is for participating effectively. But I think we should be thinking about models where we can have things happen in different places at the same time and converging to like the same picture at the end. So what I'm saying is the trade-off for me is not so clear between, if we shorten the slot time, we automatically sacrifice geographic decentralization. I think the story is a bit more complicated than that.
Won't scaling also increase the minimum hardware requirements for validators?
Yeah, so that's something I didn't communicate too much, but that's in the post that I wrote. A lot of the scaling we can do is actually asymmetrical. So it takes more resources to build for the equal amount of resources to validate. So it's not true for everything, but we can scale in a way that we are not going to increase the verification requirements for the nodes as they are, let's say, today. And then with zk-AVM and DAS, we can even shrink the verification requirements by quite a bit.
Would the light fossil model reward includers?
I don't think it should, actually. I think the fossil, generally speaking, should remain altruistic. Like it should be just a thing that you do because your node has it as a default. The minute you add like these incentives for rewards, and we thought about it a lot, and there's a really nice paper by Katrina and Julian on the topic. But it's fairly complex to design a reward mechanism that's fair first, and that also doesn't become an MEV vector, essentially, where people want to collude off-chain and game it. So I think keeping it altruistic for now is probably the way to go.
Maybe the last one. How can you prevent high-throughput machine operators from gaining too much influence over the protocol design, development priorities, and EIPs?
Yeah, that goes back to that slide with the danger zone, and something I also mentioned in the post. If you set, like, let's say, if you allow nodes to supply a ton of throughput, you can be in a situation where you create a bit of an arms race where, okay, now if I want to be an effective participant on the network, then I have to be matching like these very powerful nodes. So I think we should keep the limit a little lower than that to ensure that, no single node on the network is able to essentially accumulate so much power by being the only one that performs a service. But I think there's a sweet spot that's a bit away from where we are today.
Okay, with that, we are wrapping up. Thank you, Barnabé. A round of applause for Barnabé.
Thank you.
Thank you.